Okay, in this video we're going to explore the property of crystallinity within polymers. So part of the study design is that you can look at the percentage of crystalline areas within a polymer and know what implication that has on the properties of the polymer. So previously we've looked at LDPE and HDPE as examples of crystallinity, but more generally, if you look at the way that the chains are lined up, on one end of the scale they could be completely disordered, and we call that amorphous, meaning they don't have any kind of structure. Amorphous means not, and then morph is form, like the form of something. And then as you go along this scale, you can see that the chains kind of form more and more of an orderly structure until at the other end of the scale you've got what we call crystalline, which in the terms of polymers just means that the chains are actually lined up neatly in rows like this. Now if you look at something like LDPE, which is low density polyethylene, that's about 65% crystalline. If you look at HDPE, which is high density, made at a lower pressure more slowly, it can actually reach about 95% crystallinity, which means that 95% of the polymer is in that kind of structure. So if we compare amorphous and crystalline structures, amorphous we would call disorderly, whereas crystalline we'd call orderly. With amorphous, the chains end up being further apart. You can see this in the diagram on the left, how because of this disorder it actually separates the chains a little bit. The opposite is true for crystalline, and therefore this has implications for its intermolecular forces. So with the chains that are further apart, the intermolecular forces will be weakened by that separation, whereas when they're closer together the intermolecular forces are stronger, and so the chains are more closely bonded together, so they can't actually separate as easily. This would obviously mean that they are more rigid in a crystalline structure, whereas they're less rigid when they're more separate and the intermolecular forces are weaker. The other slightly interesting thing is that transparency occurs with amorphous. If you fire a photon of light through the substance which is amorphous, because of the separation, the light is able to transmit through the substance more easily, whereas often crystalline substances would mean that they're actually opaque most of the time.